Hello everyone, welcome to this video on the set theory. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with the e-learning partner GTCUBE Get to the Top. If you are watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of the course and also get to practice a lot of questions on these concepts that would give you a good practice and also help you understand these concepts better. So let's get started. So then the other element that you need to understand set theory is the application of Venn diagram in a word problem sort of it, right? So let's say I'm talking about is a school, right, which has some students. Let's assume there are n number of students in that school. That's like the entire list of the students in the school. And some of them play football, some of them play cricket, and some of them does not play any game, right? They play neither cricket and neither football. So how does that picture look like? So all the students who play football, I call that set A. All the students who play cricket, I call that set B. So let's assume this blue is set A and the red is set B. So this is the universe. Universe is basically all the students in the school, right? All the students in the school. So I am expecting there will be some students who will play both. That is, this zone is, I am calling it X, that is X number of students which play both cricket, football and cricket, right? And then let's say this zone, right? This entire circle is people who play football. If I remove this circular zone which actually includes people who play football and cricket, what would this be left? This is people are students who play only football, right? Understand this clearly. This is an important understanding to have. This entire circle is people who play football. Who play football as two types of people. Some people only play football. Some people play football and cricket. Football and cricket is this zone, right? Because that's overlapping with the cricket players as well. So that is X. Only football is this zone. Let me assume that to be equal to Y. And then what will this be? This entire circle B, the orange, the red circle is people who play cricket. And I know that these people play cricket as well. Obviously for cricket also it will be two, right? Only cricket or football and cricket. And obviously I know football and cricket is X number of people. So let me assume this only cricket is Z. So basically this is Z, this is Y, and this is X. So these are the three areas I have. And the remaining thing which is not, shaded per se, the one which is outside, right, this part I'm talking about, this would be the entire universe minus these three. That is people who play neither cricket nor football, right? They don't play either of the games, right? So universal set is the total number of students in school. Let's say I take this to be n, right? The entire number of students in the school is n. We'll rather get the numbers in the questions, but I'm going with the variables to just explain this clearly. So number of students who play only football, according to our diagram, what is that? That is, who play only football is Y, right? The number of students who play only cricket is Z. The number of students who play both cricket and football is this zone, that is X, defined as X. So number of students, let's come to this part. Now if I ask you, right, if I know these things, okay, let's assume I know these numbers or something. So the number of students who play football is, as I said, people who play football is play only football or football and cricket. That is, only football is Y and X is the people who play both. So X plus Y is the total number of students who play football, right? I'm basically adding this and this, both the parts, so that I get the entire circle. Similarly, for the circle B, which is the number of people who play cricket, I need to add Z and X so that I get people only play cricket plus the people who play cricket and football. So this will be X plus Z. Right, and what will be the number of students who play cricket or football? This is like basically talking A and union B, right? At least one of this, right? Even if they play one of these two games, that's fine for me. That's why it's asking number of students who play cricket or football. Right, that will turn out to be Y plus X plus Z. right? The number of people who play only football, number of people who play both, and number of people who play only cricket. If I add all three of them, I should answer this question, which asks the number of students who play cricket or football. Finally, the number of students who play neither cricket nor football, what would be that? The entire universe, basically n number of students is what I assumed, right? Let's assume the number of students is n. From this, I have to eliminate the people who are playing, cricket or football. So I just need to eliminate x plus y plus z. So that would give me this entire zone, right? These two circles will have y plus x plus z number of students who play. So I have to remove these two circles from the entire universe to get the people who play neither cricket nor football. That would turn out to be n minus x plus y plus z. Generally, is y, x and z is what you need to assume. Then they'll give you some hints in the question. Just write the equations based on it, solve them, and you will be able to answer the question. But given clues will be given like this: the number of students who play only cricket, the number of students who play both cricket and football. You just need to understand what is this they're referring to. Is it only this part, or this is combination of both, or is all three areas, etc. So immediate thing that you need to see whenever you see two diagrams with two circles is this is like y or x, z. Understand this and then solve the question based on the clues and find those values, and you'll be able to answer the question. Now let's go to a slightly complicated situation where we have three circles. That is, I have added one more game, basketball. So let's start off with the same. Let's assume the total number of students in the school is n. The number of students who play football, who play cricket, who play basketball. Earlier we had only two circles. So we had x, y and z, right? There we only had three variables. Here we'll have actually 7 variables. Let's assume this to be x, y and z. And let me call this A, B and C, and let me call this to be P, right? So that's altogether I have 7 variables. So what is this blue circle? Let me define this as people who play football. This is people who play cricket, and let me take the green circle as people who play basketball, right? So let's fill this other thing, right? Number of students who play only football. I am talking only football. I know this entire blue circle is people who play football, but I see X, A, P and C. This is all the number of students who play football, but I need to figure out the people who play only football. That is this, because it's not overlapping with other. So this A, this A is this part, right? That is, this part is overlap of this and this, football and cricket, right? C is overlap of blue and green circle and no, not the red circle. So that's why it's basketball and football. And B is overlap of cricket and basketball only, and P is overlap of all three circles. That's basically people who play all the three sports. So number of students who play only football is X. The number of students who play only cricket is Y. The number of students who play only basketball is Z. The number of students who play both cricket and football, right? So this one is a bit tricky. Based on the statement, the answer should be actually who play both cricket and football. Cricket and football is this. That's basically A plus B actually. But I'll come to this. I'll just change this to this. Number of students who play only cricket and football, right? That is, they play both the games, but only these two games, right? I'm talking about the number of students who play both cricket and football only, right? Both cricket and football only. They don't play basketball. If I just say the number of students who play cricket and football, it could also include people who play cricket, football and basketball as well. So be careful with that. That's why you have to have that explicit statement says who play only 2 games. The number of students who play only 2 games and they play cricket and football, that would be simply A. That would be this part. Both football and cricket, but not basketball. This one is basically the number of people who play 2 sports or more. So cricket and football is played by A, and also these people, they play cricket, football and they also play basketball. These people play cricket, football, but they don't play basketball. So, but you still need to count them if I go with that. Just make the same changes, only this, right? The number of students who play both cricket and basketball only. So cricket and basketball only would be this part. So that's B. Basketball and football only. Basketball and football only is C. And the number of students who play all the 3 sports is P. Right? Once I have got these 7 variables, right? Like how we had 3 variables here in Venn diagrams with 2 circles. Here we have 7 variables. So how many students play football? That is football only, football and cricket only, football and basketball only, football, cricket and basketball, all 3 games. So that will turn out to be X plus A plus B plus C. The number of students who play cricket would be only cricket, cricket and football only, cricket and basketball only, and all the 3 sports, and this would be Z plus C plus B plus P. That's the number of people who play basketball. That's how you will figure out the answers. And once you can connect all these statements properly with variables you assume, right, they'll give you some of these clues. You can just say the number of students who play football is 50. I substitute here and solve and find these variables and answer the given question. Now let's get to the Venn diagrams. In a survey, it was found that 60% of the respondents like pizza and 50% of the respondents like pasta. What percentage of the respondents like both if each respondent in the survey likes at least one of the 2 items? So that means I know that each and everyone in the survey would like at least one of these 2. So I have 2 circles. So the universe itself is this. All the 100% of the respondents would fall in this. As I said, I'll like X, Y and Z. As I said, because I know each and every respondent in the survey likes at least one of these 2 items, if I add them, that should be equal to, in percentage, you can write in the percentage and solve everything and you get the answer in percentage itself. Because anyway, the question is also asking in percentage only, right? Why did I do X plus Y plus Z is 100%? Because I know each respondent in the survey likes at least one of the 2 items. So they should either like pizza, let me call this to be pizza likers, and this is pasta, and this is both. So they like pizza or pasta or both. So they have to fall in one of these 3 categories, and I know all of them have to make 100% because each respondent likes at least one of them. What is the other clue? They said 60% of people like pizza. So what is the pizza, what number of people according to the variables? X is only pizza lovers and Y is pizza and pasta. So I have to add both. So X plus Y is 60%. And finally, pasta lovers is 50%. And that will be Y and Z, because only pasta lovers is Z and both pasta and pizza is Y, so that will be Y plus Z is equals to 50%. Right? Basic rule in algebra, 3 variables, I need to have 3 equations to solve and find the individual values. Right? So to get a unique solution. So simple, let me add 2 and 3, what do I get? X plus Y plus Z is equals to 60 plus 50%. This is 110%, X, Y and Z, they will come together, plus Y. From the equation 1, I know X plus Y plus Z is 100%. So 100 plus Y is equals to 110. So Y is 10. Once I know Y is 10, what is Z? 40%. Right? Y is 10%, Z is Y 40%, and obviously X is 50%. What is the question asking? What percentage of the respondents like both? So that's basically both is Y. That's why it's 10% is the answer for this. Right? That's how you can solve it. As I said, just note the variables properly, write the equations given as per the clues, and you should be able to solve it easily. Here it's a group of 100 kids, 30% like blue color, 50% like yellow color, and 45% like green color. So it's talking about 3 variables like blue, yellow and green. So I have a Venn diagram with 3 circles. And this is what I'll end up with. Let's say this is blue color, this is yellow, and this is green color. Right? So let me take, as I said, I take X, Y, Z, A, B, C, and the common is P. So 30% like blue color, that is people who like only blue, people who like blue and yellow, people who like blue and green, and people who like all 3 colors. So X plus A plus B plus P is 30%. Right? People who like blue color. People who like yellow color would turn out to be Y plus B plus C plus P. Same, right? Only yellow is Y, yellow and blue is B, yellow and green is C, all 3 colors is P, that is 50%. People who like green color is 45%, that is only green is Z number of people. People who like green and blue is A, and then C is for green and yellow, and P is for all 3. So A plus C plus P is equals to 45%. Right? Then it is also known that 15% of the kids like both blue and yellow. Right? So that's basically saying 15% of the kids both blue and yellow is 15% of the kids, right? So 15% yellow, both blue and yellow. So let me take both blue and yellow is this part. So again, as I said, should I also count P? Ideally, you should, based on the way the sentence is. It is also known that 15% of the kids like both blue and yellow. So these kids like both blue and yellow. These kids also like both blue and yellow, but they also like green. So it should have been people who like both blue and yellow only, right? Both green and blue only. And 18% like both yellow and green only. They have to be explicitly mentioning this. Okay, let's solve this assuming this only is what they have given. Both blue and yellow only, that is B is 15%. Only green and blue, that's basically, that's green and blue is this part, that's 18%. Only green, sorry, yellow and green would be, yellow and green is this part, that is C is 8%. And then 8% like all three colors, that's basically P, right? So P is given as 8%. This is 18, sorry, this is 22%, and this is 18%. B is people who like both blue and yellow. Blue and yellow is liked by 15%. 22% like both green and blue. Green and blue is A, that is 22, and C is 18% who like both yellow and green, and 8% like all three colors. So they gave us B, A, C, P. So I can substitute here A, C, P, B, C, P, A, B, P to get X, Y, and Z. I know all the values that are, as I said, 7 equations, 7 variables. That's good enough for me to answer it. Any other simple equation is straightforward, give the equations. Let's assume if the question did not have these only words, okay? What would that lead to? Then as I said, I should count that blue, right, and yellow is liked by people who like both blue and yellow only, and P is the number of people who like all three colors. That would be 15%. A plus P is 22%, and C plus P is 18%, and P alone is 18. So 8, right? 8% is like all three colors. So if I know P is 8, then automatically implies C is 10. This implies A is 14, and this implies B is 7. You know, I can also do this and do it. So as I said, the answers would come different, but you can calculate. There's nothing different in terms of complexity in solving. It's just about how the answers would vary. So let me do with this. Right? A is 22%. B is 15%. That actually is giving me a wrong answer. Why? Because you see this. X plus A is 22 plus B is 15 plus C is 18. Sorry, P is 8. So this is like is equals to 30% is what the statement 1 is, the equation 1 is, but this alone is more than 30, right? This will come to be 45, which will give me X as minus 15%, which sounds like a wrong one. So I guess let's actually, you know, do it without the only word, that is this approach. A is 14, B is 7, C is 10, and P is 8. So what would this turn out to be? X plus A is 14 plus B is 7 and P is 8 is equals to 30%. So that will give me X as 14 plus 7, 21 plus 8, 29. So 30 minus 29 is 1%. Right, that is still giving me positive value, that's acceptable. Now let's come to second equation. Y plus B is 7, C is 10 and P is 8 is equals to 50%. 17 plus 8, 25. So 50 minus 25 is 25%. That Y is 25%. Similarly for Z, it will be Z plus A is 14, C is 10 and P is 8 is equals to 45. So 24, 32. So Z plus 32 is 45 and Z is 13%. Right? So basically this is wrong because we are getting a negative value. So this is how it should have been. So that's why I think the question is correct. So it does not include only words. Right? So it is also known that 50% of the kids like both blue and yellow. What you have to understand is both blue and yellow is not just this thing, also this thing. Right? That's why you have to write B plus P. Why? What is B? The kids who love yellow and blue only. That means they only like these two, they don't like the green. This is people who, the kids who like yellow and blue and pink also. But the clue is saying that 15% of the kids like both blue and yellow, which is acceptable for this and this category. So we need to add 2 colors plus 3 colors, 2 plus 3, 2 plus 3 for this individually. Once I do it, I know all the 3 colors are liked by 8%. I can individually find only 2, only 2 and only 2 and then substitute it back here to get only one color. So how many kids like only one color? X plus Y plus Z is the answer for this. Right? X is the number of students or kids who love only blue. Y is the number of kids only like yellow, and Z is the number of kids only like green. So I just need to do 1% plus 25 plus 13. Right? This will turn out to be 39%. So that's the answer for this. Right? That's how you'll solve this questions. Right? It's simple once you get hang of this application, like 3 circles have 7 variables x, y, z, a, b, c, p. Just understand the x, y, z are only one color, a, b, c are only 2 colors, are liked, are loved, and p is all 3 colors. Right? That is how you should have the 7 variables. And accordingly write the clues proper way and get the answer. So thank you for watching this video. If you're watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of the course and also get to practice a lot of questions on these concepts. Also like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of content that would help you in your preparation. All the updates and notifications will be shared over there, so don't miss that. So thank you for watching, and let's meet in the next video.